looks like he'll be bored with the video.
Hi, everybody.
Last time I've got scheduled for time with you today, and I couldn't in good sense leave you without knowing the additional pieces of the core. Now, we know the Iowa Core's got our content standards, what we are mandated we need to have our students learn, but it also has our standards of mathematical practice, and then the Iowa Core also has every math standard matched to a depth of knowledge, and I'm going to be working with our lovely acronyms because they're too long to say. So SMP is going to be our standards of mathematical practice, and they are K-12, none of us are exempt. And the depth of knowledge is also K-12. So that's what we're going to focus on today, and it's just the additional piece of the core, so it's kind of a dual prong with our core, content standards and mathematical practice standards. Okay, so what are they? Well, that's the official definition, defining the expertise. But folks, it's really what our students are doing and demonstrating that they know. That's what these standards are going to tell us about. What are the students doing that are demonstrating they're learning what we're asking them to learn? That's what the standards are going to be doing. So they were put into the core when the core was first made. Now, if you've been teaching for a while, this was the very first document that came out in the 21st century to guide our thinking for best practices in mathematics. And so this, if you've been around, this was published in the early 2000s, and it really contained our process standards, problem solving, reasoning and proof, communications, connections, and representations. And this was really a biggie at the time, having students talk to one another. This is when our classrooms went from teacher-directed and students sit and get to students actually working and talking with one another. That's one of the first things that came up. So we're going to pull from that document, but then the next year the National Research Council put out this one, and this particular document had different strands, and it says at the side, adaptive reasoning, strategic competence, conceptual understanding, productive disposition, and procedural fluency. And this was different than the other one, and the items that were different than the other one was the strategic competence and the productive disposition. So the best minds that were thinking about math, how our kids are going to show us they learn, got together, and when they got together, this is the bulleted form of what the new standards of mathematical practice are. This is like the Cliff Notes version, okay? So you're going to see this in every page of your Iowa Core, and they are: make sense of problems and persevere in solving them, reason abstractly and quantitatively, construct viable arguments and critique the reasoning of others, model with mathematics, use appropriate tools strategically, attend to precision, look for and make use of structure, and look for and express regularity in repeated reasoning. So, I'm going to hand out to you a couple of things here. I want you to take half my book at a side. And I'm going to, this is a direct print off from the Iowa Core. There's three there.
Hey, was that a title of the book, Adding It Up?
Yeah, it was.
You have that.
I guess it is. We need one more there for Amanda.
Just like the kids in my class.
Okay, so if you have your Iowa Core book, if you don't, you can see me and I'll get you some. So the Iowa Core document itself, pages 8 through 10 of this, that's what I've got for you, the first standards of mathematical practice. So I want you to try to take a look at those standards. And here's what I want you to do. Just take a minute and look at the first 3 words of each of these practices. There's the first 3 words. What do you notice? Wouldn't that be great if all of our students were mathematically proficient for each grade level? That would be swell. So these are going to help us to guide that, because that's what we want for all of our students, to become mathematically proficient. So now, I want you to take a scan of each of the standards. Let's take, 45 seconds to a minute. And I want you to try to notice some of the verbs you're going to see in each of these paragraphs describing the standards. So just scan them, looking for verbs. things are you noticing? What kind of words stand out to you?
Analyze.
Analyze, what else?
Explain.
Explain. Reason. Justify.
Instruct.
Instruct.
Discern.
Discern. Notice. Okay, these are just some ones that jumped out at me. These are not, the major ones, but we said explaining, making conjectures, make sense of, understand, use, apply, interpret, consider, detect, communicate, but you communicate precisely, discern, recognize, notice, pay attention, justify. Those are all big verbs. So you get the idea that our standards are a lot of doing of math, but they really have a dual nature. So they do describe the content, and in our first standard, the one that says make sense of problems, this is a part of it. Students can explain correspondences between equations, verbal descriptions, tables, graphs, and draw diagrams of important features and relationships, graph data, and search for regularity or trends. That's one hand, but on the other hand, I want them to be learning, to be thinking, to have the habits of mind, to reason, to problem solve, because they also say, as you pull out, analyze. The students analyze givens, constraints, relationships, and goals. They monitor and evaluate their progress and change course if necessary, and they continually ask themselves, does this make sense? And a lot of people try to categorize our standards. Now, these are standards 1 and 6. They kind of work well together, and sometimes those are called our habits of the mind, also our problem-solving standards. Standards 2 and 6, that's your reasoning and explaining. Standards 4 and 5, that's your modeling or the using the tools. And standards 7 and 8, that's for seeing the structure, for generalizing, for looking for patterns. And so it helps me when I'm looking for what students are doing, how they're demonstrating it, if I think of them in those categories. And these categories were first made by Bill McCullum. He is one of the lead writers at the Corps, and he is the one that came up with those categorizations of the standards. So I've got pictures up here of kids doing math, demonstrating their learning, because that's what these standards are telling us to do. But to get all kids to do it, for that to be equitable in learning, I'm going to have to choose mathematical tasks that use a variety of resources. Some bodily doing things, some manipulatives, some talking, some writing, some doing on technology. There's going to have to be a variety to get the needs of every kid met. That's a huge piece. So, how do you go about finding all these appropriate things for students to do and demonstrate? We're going to look to the core. That's going to be our guiding document. We know we've got our content standards for what I'm teaching. I know I'm going to have how students do it and demonstrate it. I know I got to focus in on just what the course says. I've got to work with coherence. Well, if they did this in first grade, it pulls through. They do this in second grade, third grade, can rely on this, and there's a lovely coherence between the grades. But this rigor, that's conceptual understanding, as well as procedural understanding, your fluencies, and your application of problem solving, all that's contained in that little bitty word. That's huge. And then the depth of knowledge comes through. So, do you know what a depth of knowledge is, where it came from? Clueless, right? That's okay. What is it? It's a scale of thinking complexity. Now, this is not like a taxonomy. You may be familiar with Bloom's, where Bloom's has got these 6 layers. It's a hierarchy, and the low one is the knowledge, the memorization stuff, and the new revised one's got creating up at the top. It used to be analyzing, but now it's creating. Okay, this is not that. It's not a taxonomy where one's better than another. Okay, this is thinking complexity, and there are 4 levels. It was developed by this gentleman, Norman Webb, and he comes from the University of Wisconsin, and his research on that is all about
trying to match all of our learning with the level of complexity of thinking required by everybody. It also is what's driving our assessment questions. So when you're taking either the Iowa assessments, or if we ever go to Smarter Balanced, or whatever the state moves us to, they draft their questions on the assessments based on the complexity of thinking required by the Iowa core for each domain, cluster, and standard. It's kind of deep. So, this cognitive demand. It's the kind of level of thinking required for students to engage and solve a task, and it's ways our students are going to be interacting with the content. Now, in your packet, the first 3 pages, pages 8, 9, and 10, were the standards of mathematical practice. Now, the next piece stapled to it jumps to page 99 and 100. Our Iowa core document gives us a synopsis of what the DOK levels are, and there are 4 of these DOK levels. So they're going to focus on the complexity of the content standards in order to successfully complete a task or an assessment, but what students are producing, the outcome, the product, is what drives our DOK level. Okay. Where's all this going? Well, it's been several years that we've had the No Child Left Behind Act, and that's where this was first brought up. Okay, No Child Left Behind's been reauthorized a couple of times, right? Why have we not really paid much attention to it yet? Well, we now have assessments that are more closely monitoring how our students are performing, and so we really have to make sure that we're making their brains grow in the right ways. So that's why we've got the depth of knowledge. The 4 levels are: level 1, recall and reproduction. Don't I want kids to know my basic facts? To supertize, no instant, this is a 5, this is a 6. I mean, that's recall. This isn't bad. Everybody should have level 1 learning. It's not to be avoided. We have to have that. Level 2 is our skills and our concepts. I have to apply something. Level 3 is our strategic thinking. I'm going to have to do more than just follow an algorithm. I'm going to have to apply and analyze and maybe justify a little bit, explain why I'm doing something. And level 4 is extended thinking. Now, in our Iowa core, there is 1 DOK4 in the entire mathematics Iowa core that's found in high school geometry. Okay? The last page of your handout that I gave you includes this poster. And I bring it to you here because notice my strange design numbering. I don't have to start at level 1 before I can go to level 2. That's not required. And it doesn't mean that my very earliest learners can't do 3 and 4. So here's just a real good overview of the depth of knowledge, and to remind you that they are not sequential, and 2 level 1s does not make a level 2. Okay, so that's why I gave you that poster. So here's some examples for math. These are DOK level 1s. So if I have the fractions 2/7, 4/7, 6/7, 8/7, and I ask you to find the next 3 terms in it, what am I doing to my numerators? Adding 2, so it's going to be fairly easy to say add 2, add 2, add 2. So what are my next 3 terms? Yeah. Pretty easy recall. I know what I'm doing, just a procedure. Now that would be a 4th grade standard. Here's a 7th grade standard for a DOK level 1. The price of gasoline was $2.25 per gallon last week. This week the new price is $2.33 gallons. Determine the percent of increase. Just following a procedure. That's all that is. That's a DOK level 1. FYI, I'm going to give you a group quiz in about 20 minutes. So pay attention to my DOK levels. I'll give you some collaboration practice time first, but kind of pay attention, okay? Just let you know. So depth of knowledge level 2 examples. So my first question is a 4th grade standard. Draw the next figure in the pattern. What might it look like?
bottom, followed by
3 in the next row, 2 in the next row.
pyramiding up, right? So I'm going to have to first look at this and find how my pattern grows. So my base is a 1, my base is a 2, my base is a 3, so the next time the base has to be a 4. And does it come up with less each time? Yes. So I'm going to have to do a little bit more than just know it. I'm going to have to look and think about it a little bit more extended thinking. And in 7th grade, on a trip across the country, Justin determined that he would have to drive about 2,700 miles. What speed would he have to average to complete the trip in no more than 50 hours? So I'm gonna have to do a little bit of thinking. I don't automatically know to add, subtract, multiply, divide. I'm gonna have to work on some things to get there. It's a depth of knowledge level 2. Questions? Okay, so here's a 3. Depth of knowledge T. Now this is getting to that strategic thinking. Find the next 3 terms in the pattern and determine the rule for the following pattern of numbers. Again, I picked on 4th grade. So I have a 1, 4, 8, 11, 15, 18, 22, 25, 29. So, it's not maybe quite like you thought for some of the others. Can you see anybody what they're doing? Add 3, add 4, add 4. Add 3, add 4, add 3, add 4, add 3, add 4. So it's not the same thing, it's not growing exponentially, it's got a revolving pattern back and forth. And that's going to be a little bit harder, that's a depth of knowledge 3. And again, in 7th grade, a sweater that you really have wanted has just been placed on sale. The original cost was $63.99. The sale price is $47.99. So what's the percent of decrease from the original price? But you still don't have enough money saved up to purchase the sweater, so you wait just a little bit longer, and the store has now an ad that states that all items currently on sale have been reduced by 1/3 of the sale price. So what's the new sale price? And what is the overall percent of decrease from the original price? Gonna have to do a little bit more than just put in one percentage multiplication problem, right? A depth of knowledge level 3. This is the only one in geometry. This is high school. Look what this depth of 4 standard is going to ask them to do. This is high school work. Apply geometric methods to solve design problems. For example, designing an object or structure to satisfy physical constraints or minimize cost, working with typographical grid systems based on ratios. Now, DOK level 4s are over time. Yeah, geometry, high school geometry. Our kids will do this. This is a major standard. It's not one of those supporting or additionals. It is a major. This is what our high school geometry students will be working on. And since it is a depth of knowledge 4, it's over time. This really could take them 5 days of block schedule time. Regular class grade could take a couple of weeks to do just this one standard. So Iowa Corp only has one of them. Here in elementary, we don't have to worry about it. So, this is group effort, group talking. All right, this is your collaboration time. Pick on the brains of your colleagues. Look at your pages 99 and 100 that are copied for you. And I want to know, what level DOK are these? Number 1, given the coordinates for 3 vertices of a rectangle, students will graph the coordinates of the 4th vertex. Is it a 1, 2, 3, or 4? That's your talk with everybody, figure this out.
The higher it goes up, the longer it should take them to solve it.
That is seeming to be true. Level 1 should be really automatic, but if it's a process, an algorithm that I'm just following for like a volume formula, it may take me a little while to get through it for time-wise.
But at least it's a set structure.
Right.
Creating, interpreting an order, yeah. I'm gonna go
Okay, on number 1, what say you? Is this a 1, a 2, a 3, or a 4?
2.
2? I like 2. I like 2 very well. Mainly because I'm going to have to visualize this. I'm going to have to know what a rectangle is. That should be an automaticity. I should be able to know and recognize my shapes. I'm already given 3 of them there's only one place left that it can go. But because I have to visualize it, I don't think it's a level 1, it's not an instant recall. It's not a fact like 2 times 5 is 10. Okay? Let's go to number 2. Students will graph the point in order to pair 1, 6 in the first quadrant of the coordinate plane. What say you? What DOK level would you put that? Talk among yourselves.
There's only one possible answer.
And level 3 can have more than one candidate. Yeah, it's not only one answer. Response or approach is often. So we have 2.
Okay, what say you?
2.
2s? 1s? We have a divided room. I'm going to suggest to you that it's a DOK level 1. There's only one place to put it, they told you exactly where. They told you where to go, they told you what quadrant, you don't have to deal with it, poof, that's it, they told you. True. True.
Oh,
Okay.
we're not talking about second, right?
And I have these all over the place for standards. Okay, here we are. Number 3. Students will graph the vertices of a triangle onto positive coordinate planes using different scales and analyze what changes in the figure are affected by the changes in the scales and explain why. What DOK level might that be? I bet you don't say 1.
I would say
And explain why. So you have to explain why. So.
Explaining why we want the 2 though.
Yes, but often need to provide for support.
I wanted it to make some sense.
Okay, did I give you enough time to ponder this one?
I'm going 2 or 3.
Okay, I heard 2 or 3. I have a 3.
We say 3.
We say 3? This half of the room collectively says 3? Okay, I'm gonna say it's a 3, and I heard you pick up on explain why, but it's 1 and it's different scale and it changes. So I'm going to have to be able to apply a little bit more. If it didn't change scale, I'd probably put it as a 2. But it changed scale, so it's gonna change what it looks like, and I'm gonna have to really think about that. It's gonna take what they call that strategic thinking. It doesn't move to level 4 because it's not over time. I don't have to do this to fix this problem, to check it out, and did it work. It's not a 4, so it's just sitting at a level 3. All right, last one. Students will graph the vertices of the reflected image of a triangle. Talk amongst yourself on that one.
Because it's not reflected. Because they're but it's reflected, so all I have to do is flip it to the other side.
There's only one right answer.
Yeah.
So unless you put one in.
I'm also they just have to flip it in the side. But you're not looking at the image as the way they want you to see it.
Okay, did I give you enough time to ponder over this one? Okay, so what say you about item 4? What DOK might it be? We're seeing a 2? We're seeing a 2? It's a 3.
Oh my goodness, really?
Did they tell you which way to reflect, over X or over Y?
Oh.
Did they tell you what kind of triangle?
Well, if it's how they did it.
Okay, but they didn't tell you that,
I thought that.
okay? Did they tell you what quadrant to keep it in? Did they tell if it was
Talking to.
a coordinate plane or a polar plane? Oh. Oh.
We don't care.
Okay, so folks, a DOK is not a taxonomy. Level 1 is good, level 4 is good. I don't have to worry about ratcheting up. It's not a taxonomy. It's not the same thing as difficulty. It's not about the verbs. Remember in Bloom's there's these great little wheels that you're trying to pick out the verbs to go there? Well, some wizard along the world tried to take Norm's depth of knowledge chart and put it in a wheel and put verbs to match it, and I'm gonna tell you, it's not about the verbs. What's it determined by? The depth of thinking, because verbs are not always used appropriately. So I'm going to talk about explain first, the next slide's going to talk about analyze. So, this one, explain to me where you live. It doesn't raise the depth of knowledge level, it's a simple rote response. I don't care if you have to give me your street address, or you have to give me landmarks to the big cotton tree. Okay, it's still just recall. What comes after the verb is more important than the verb itself. So here's the word analyze. Now normally in Bloom's, analyze would be a pretty high level, wouldn't it? But analyze this sentence to decide if the commas have been used correctly. This doesn't meet the criteria for high level thinking. If I've been taught a rule for using commas, it's a DOK one. Analyze isn't going to be that higher thinking. So it's not about the verbs. So let's look at 3 different levels. In a DOK 1, I'm going to use the verb describe. Describe 3 characteristics of metamorphic rocks. Isn't that just recall? But if I'm working on a DOK 2, describe the difference between metamorphic and igneous rocks. I'm going to have to process the different types. What if I put it into a 3? Describe a model that you might use to represent the relationships that exist within the rock cycle. I'm going to have to understand that there is a rock cycle to begin with, and then determine those relationships. And how do I want to get my idea across? How do I want to represent it? So it's not about the verb. So what is it? It's about the outcome, the product, not the difficulty. So it's a reference to the complexity of the mental processing, the thinking, that has to occur. So, do we agree that adding could be a mental process? Sure. Okay, because knowing the rule for adding is the intended outcome that influences my depth of knowledge. So I could say, if once I learn how to add the rule, if I add 4 plus 4, it's a DOK 1, and it's easy. But what if I make them go to the millions? It may be a little bit more difficult, because I got to, do the adding, and I'm going to have to do the regrouping and all those kind of things. But it's still a DOK 1, I'm still following the adding rule. So it's really not about difficulty, it's about the complexity of thinking. Another example. Difficulty is a reference to how many students answer a question correctly. So if I ask you how many of you know the definition of the word exaggerate, it's a depth of knowledge level 1. If I know the definition, it's easy. But if I just change, and instead of asking exaggerate, I ask prescient. If you don't know that definition, it's difficult. It's not more complex. You know what prescient means? I had to look it up too. The knowing of something going to happen before it happens. That's what prescient is. So it is about complexity, not the verb, not difficulty. It's about the learning outcome, it's about the product, it's the complexity, it's the intended student learning outcome that determines the DOK level. Every single standard in our core has one. And what I did to help me through and I'll pick, I've been picking on fourth grade all day, so I'll stay with fourth grade. I went to fourth grade, and this is the first 2 pages. Can you see hot pink in there? I highlighted every time a DOK3 appeared in the core. Our textbooks are really good at DOK 1s and 2s. They're gonna give you things to compute. They're gonna give you the random problem solving, which always matches the topic of the day. Doesn't require a whole lot of the strategic thinking. So the core is gonna guide for me where I'm gonna go look for my tasks to match the DOK3. That's what I have to do, and I have to make sure when I'm looking for my tasks, where's the most bang for my buck? The core tells me. The DOK3s, they're generally not in our textbooks, not even in the brand new textbooks, so I'm gonna have to go look for those. All right, this is a group quiz. I got 3 questions. All right, you ready? Fill in the blank. What blank the verb is more blank than the verb itself when deciding the DOK level? What kind of words might you put in there? Talk amongst yourselves. Okay, keep talking.
More important. What follows the verb is more important than the verb itself.
What, you said what follows the verb is more important.
than the verb itself.
Great. What's the difference between difficulty and complexity, according to thinking in the depth of knowledge world? Not as definition world, depth of knowledge world. Yeah, I'm hearing the exaggerated prescient thing. In other words, you know, it's not about the verb, is it? And so that's the example I used. It's not about the verb. Here's your last one. What really determines the DOK level? There's one, amount of thinking required.
Reference to the complexity.
The number of steps or multiple.
The mental process.
Aha, I heard it. The product. The product. So here were your answers. Okay? So knowing I got these standards of mathematical practice, what kids have to do and demonstrate that they know. How am I going to get them to do it? Well, I'm going to have to pay attention to DOK levels in my core. So what would I do next? Now that I know I have to do this, what does it mean I as a teacher have to do? Well, I'm going to tell you to go to the core. The very thing I want you to do is to highlight every time a DOK shows up. They start in kindergarten, they go through high school. Go find out what those standards are. Then find tasks. You don't know where to find them? Hello, ask me. I'll help you. And then remember, your textbook, it's just one tool in your toolbox, and they really only write to DOK level 1s and 2s. Does that make sense to you? All right, so this is the last time I'm going to see you formally this year. You can call me anytime. But I would like to find out, what do you think you need help with? Whether it's whole group, whether it's individual, whether you're moving levels, you're going down to 3rd grade, I think, coming down to 3rd grade. So I have a simple checklist, okay? And I want you to go through, and anything that applies that I need help with this, check it off. What if you're all good? There's this thing called other. Say, nah, I'm good, okay? Name is optional, but would help me, and grade would be even better, because if I'm looking at these and I see that such and such needs this, well, what grade level do I need to focus on? So, if I could please have you do this, and then as soon as it's done, unless you have further questions for me, that's all I have for you. I'm not very good at dividing these, there's a couple there. And once again, I need one for Amanda, I'm not good at dividing.